him. Kill the guy now. Grab the gun. Hit him.
What?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there's football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting off in your dream. That's the reason why you have F's in your courses, like they're specially made for you.
I have you last semester.
We £5 on you. Very stupid though. We are changing that station to ACTV right now. And oh God, the people who have been first born. Stupid boy.
Hello everyone, welcome back to class. I hope we have a very lovely day. From the previous class, we talked about the measures of central tendency, and I hope we have gone through the notes. Today, we are going to be talking about measures of dispersion or variability. And I want to tell you that if you do not understand the first aspect, that's the measures of central tendency, it will be difficult for you to grab this one. Now, let's look at what we have in measures of dispersion or variability. The first one we'll talk about is range. Now, talking about range, range is the difference between the greatest and the smallest of a distribution. Now, talking about greatest, the highest. So, the highest of that particular distribution and the lowest, then you now get the difference. What I'm saying is just that it involves just two extreme numbers. Now let's look at what we have here. Look at example where I have 4, 4, 4, 5, 6, 5, 7, 8. You can see that the highest that we have here is 8. Then the smallest here is 4. Now subtracting 8 minus 4, you have 4. That is the range. So it is not a very reliable measures of dispersion because it is only involving two extreme numbers. Now we have another one, which is standard deviation. It is being symbolized as sigma. Sigma is the symbol. It uses deviation of all members of data set from the mean. I don't know if you get that. So the deviation that all the members of the data is having, the deviation from the mean, that is what we use in calculating the standard deviation. So it is the most useful and commonly used for measures of dispersion. So then it is the square root of variance. What is variance? It is measure how spread a data set is. Now, why do we need to look at all these things? They are very important. Is to look at the major importance is to look at how spread that data is. So, for you to know how spread the data is, you need to calculate your standard deviation and variance. So, then it is your mean. It is the calculation from your mean that you will use in calculating the standard deviation as well as the variance. Now, let's look at the formula for calculating the variance, standard deviation. Look at the first one that we have here. This is the variance. This is the symbol of variance. You have the summation x superscript I over the mean. The x that is carrying the bar is the mean. Then over n. N is the sample numbers, the sample size, minus 1. Sample variance. So that is how you calculate your sample variance. Then this S is your sample standard deviation. I told us that it is the square root of sample, the variance, the standard deviation, it is the square root of variance. Now we have the summation of x superscript I also minus x bar, which is your mean, raised to power 2 over n minus 1. Then another thing that you need to first calculate that is also very important is you need to check your mean deviation as well. Mean deviation, that is the deviation from the mean, whereby you have your summation the summation over into bracket x superscript I subscript I minus x bar over n minus 1. You could see that the two of them they have their own difference. The only thing that you don't have here, the square that is here will now be square for the standard deviation. But for the mean deviation, there is no 2 here, as we can see. So this is when you want to calculate for ungrouped data. Then the situation is different when you are calculating for group data. The presence of frequency, it is very important when you are calculating for the group data. Don't forget, the last class we talked about what makes a data set group and ungroup. I told us that when the sample size is too large, you go for group data, you group them. But if the sample size is not large, there's no point in grouping them. You can just calculate for them. But in a case whereby we have them being too large for you, so then we can group them to make the work easier. So when it comes to a group data, the formula for variance and standard deviation, the two of them will carry the frequency. As you can notice the difference here, you see that this one is having the frequency that is absent in the group data. I don't know if we are getting it. Now let's look at what we are saying. Example, compute the mean deviation, variance, and standard deviation of the following data. Now, here comes the measures of the central tendency. The first thing you are going to calculate here is you calculate your mean. And I told us that how do you calculate your mean? You add up all the data set, then divided by the numbers of the sample. So here you have 18, 19, 17, 18, and so on. You add everything all over, then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where we got our 10 from, so that you not be looking at where did this 10 come from. So it's because of the numbers of all the samples. Then so you now add up these, we have 181 divided by 10. So that gives us 18.1. Our mean here is 18.1, and this mean, it is what we are going to use in calculating our standard deviation. Now, the first thing you are going to do is make a column. Here I have 3 columns. The column for the x, which is the sample. Then the column for the x minus x bar. Don't forget, this is the x. You have your x here. Then the x bar is the mean that you have calculated, the mean. Then you will now square the mean. You square the x minus x bar. Because if you are going to add up all this one, you are going to get a negative figure. And we don't want a negative figure. So now I have my x. Then I have my x, which I have 18, 19, 17. Then how do I now get x minus x bar? Don't forget, the last time we got our mean to be 18.1. So now we have it as 18 minus 18.1. That's why we got our minus 0.1. I'll go over it again. I said you have your x. This is x, 18. Then your x bar is the mean you have calculated from the previous calculation. So which is 18.1. 18 minus 18.1, you have minus 0.1. Then you squaring minus 0.1, you have 0.01. You can use your calculator to verify that, and that is what we have done for all of them. If you use your calculator, 19 minus 18.1. In this case, 19 is higher than then 18.1. So you have your 0.9. Then you square that, you have 0.81. Then likewise, that's how you calculate for all the data. So you have your minus 0.1. Then after this, you can add up. But in this case, for ungroup data, we don't normally measure the mean deviation for, because if you look at it, if you add up all this one, you are going to get 0. So what is there to calculate? So for ungroup data, there's no need for calculating for the mean deviation, but we're going to calculate for the standard deviation. So now, the next thing you're going to do is add all this up. You add all this up. That's what you use in the net calculation. So what do we have? Like I said, note. So I just told us how we got our 0.1. Then how we got our x minus x bar raised to power 2. So all what you need is just to square it. Then the total, that is the summation of everything that you have added, is 7.4. I hope we are there. 7.4. Now, when we have your 7.4, how will I calculate my variance? Now, don't forget the formula that we have. That is summation into bracket s subscript I minus x bar. This is supposed to be x bar. That's your mean raised to power 2. Then divided by n minus 1. You don't need to be looking for all this one again, because we have done it already in that table. So all this one, all what you need is just to add this up so as to ease your calculation. So after I added everything up, I got 7.4. And 7.4, that's for the up. Then where do I get my 9? Don't forget our n. You count the number. How many rows do we have? How many is the data? So that is 10. So 10 minus 1. That's where I got my 9. Then 7.4 divided by 9, I have 0.82. I don't know if you are getting that. So this is for variance. Our variance is 0.82. Now, if I got my variance, standard deviation is very easy. So I calculate for my standard deviation. All what I need is just to square it. So square 0.82, you have your 0.91. 0.9. So it's so easy. All what you need to do is to master the word, to master the formula. When you know the formula, you know what you are sorting for. So here you have calculated your what? The variance for the group data and standard deviation for the group data. Don't forget, I said it's not necessary that you calculate for mean deviation in an ungroup data. Let's now go to group data. I'm still using that particular set also. The distribution that we have in the first place, that is what I'm also using. Don't forget, you can go and look at the distribution set. We have 17, 18, 18.5, 19, 19. Instead of having like 10 of this sample, now I want to group them. Let all those ones that are 17, let it be one place, 18, one place, 18.5, one place, then 19. Then now, that means that they now look at the frequency. F means the frequency. That means in that data set, 17 occurred 3 times. 18 occurred 3 times also. 18.5 just once. 19 2 times. 19.5 once. You see, I have made the work so easy. Instead of listing, I just try to compress them to make it work, to make it easy. In fact, it will even be easy when you are dealing with a large set of data like this. Now, what's the next thing? Don't forget, we have calculated our mean. It's still the same thing. Our mean still remain 18.1. If you want to verify that, add all the fx. Look at this place. Fx, add 51, 54, 80.5, 38, 90.5. Add all of them together. You are going to get 181. Add them to verify. So now you adding all this fx divided by 10 also. That is f. So, and that makes us, don't forget the how to calculate mean for the group data. I told us that it will be summation fx over what? Over f. summation fx over summation f. So add this up, which will be at the numerator, and f will be at the denominator. So you add them, you are still going to get 8.1. So your 8.1 now minus 17. 18.1 minus 17, you have your minus 1.1. 18 minus 80.1, you have minus 0.1. I hope you know that when you are subtracting, a lesser number from a larger number, you're going to get a negative number. Are you getting me now? So that is why we are having minus. So you have to take cognizance of it. So now 18.5 is higher than 18.1. You are not going to get any minus again. It will be 0.4. 19 minus 18.1, 0.9. Then I now move to f into bracket x minus x bar raised to power 2. That is, I want to scale it. So now for your minus 1.1, what you are getting is 3.63. 3.63, as you have gotten here. Minus 0.1 square. Minus 0.1 minus 0.1 square, you are getting 0.03. Then 0.4 square, 0.16. 0.9 square, 1.62. 1.4 square, 1.96. Add this. It is very important. At the end of all your calculation, you add up. Add this up. Add this, add this, add this. But what we need here now is we need this one. We need this one to calculate our, okay. We need this to calculate our variance and as well as our standard deviation. Let's look at the next one. How is it going to be? Like I said, your f is 10. Where do I get it? The total number of sums. So when you see n and f, and we are talking about the same thing. Excuse me. Then you have your summation. Summation of f into bracket x minus x bar raised to power 2 is still the same thing, 7.4. What I'm saying is that when you add this 3.63, 0.03, 0.16, 1.62, 1.96, when you add them together, what you're going to get is still 7.4. Are you getting me now? Then you have your fx, like I've said, 181, so you divide them. You don't need to bother yourself again since you know the mean. Then, now let's look at it. That's why it is very good that you have solved for all this before. All what you need is just to substitute. I don't know if you are getting it now. So you only need to substitute. So the substitution for the summation f into bracket s subscript I and that is 7.4. Still our n is still f. So that is 10 minus 1, which is 9. You are still getting the same thing, 0.82. Now, we are sorting for the mean deviation now. How do I get the mean deviation? So that takes us to this the second column that we have here, which is x minus x bar. So the total of this, so 0.4, 0.9, 1.4 minus 1.1, minus 1.1, minus 0.1. So all the total, we have it as 1.5. Then your n also is still n minus 1. Then 1.5 divided by 9, you have is equal to 0.167. That's your mean deviation. So you can tell me that your standard deviation will still be 0.9 because that's what we got in. So now you can now see the difference that when you are even calculating for the group or on group, it is just to make your work concise so that you will just avoid unnecessary repetition. So that's why we normally go for group. So you see that even for the group and non-group, we got the same answer. So by I don't want to rush us too much, but one thing I have established now is that for you to know how spread the data is, you must work out your variance. You must work out your standard deviation. So, and you cannot work the standard deviation without computing for mean. You can't work your standard deviation out without what? Having your mean solved for. So you have to get your mean. Then sometimes you can work out your mean deviation. So all those things are very, very important for you to take notice. Then you can as well as try this at home. So this is your X, which is your sample. Then F, that's the frequency of what you are going to solve for. So you calculate for your Fx. So that is telling you that F and X. So it's 44 times 5, 44.5 times 7. So that's your Fx. Then you look for your mean first. And after you gotten this, then you solve for your mean. So your mean your X minus mean. That's what. So what you get here. What you get here, you're going to what? Square it here. Then after squaring it here, then you are going to multiply it by F. So it will make your work easier. So calculate the mean deviation for this, variance for this, and standard deviation for this. My email is displayed on, so you can actually send your correct answer to me. So thank you, and keep safe till we meet next class. Thank you.
Finish him. Kill the guy now. Grab the gun. Hit him.
What?
What is this? Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting for in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have last semester.
We eat by pounds on you. Very stupid though. We are changing that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.